Okay, so we're going to go over these similarity notes here. Remember, similarity, we're talking about similar polygons. So two shapes, they are similar to each other, and it's kind of related to dilations because when we perform a dilation, we are creating two similar figures. So what does this actually mean? Polygons that are similar are polygons that have the same shape but different sizes. So we can have two triangles, but one's bigger and one's smaller. Now there's some other things that need to be true in order for it to actually be similar and not just two triangles. So polygons are similar if one way to tell is that all corresponding angles are congruent. So as you change your size, the angles will actually end up staying the same. So all corresponding angles in similar polygons are congruent. The second way is that all corresponding sides are proportional. So the sides are no longer congruent. They're not the same size, right? Because our size gets bigger or smaller, changes. But they change proportionally. So that means if one side doubles, all of the sides double. Or if I take a third of one of the sides, I take a third of all of the sides. They get bigger or smaller by the same amount, by the same ratio. And the ratio of the corresponding sides, the way that they get bigger or smaller, is called the similarity ratio. And now the similarity ratio is pretty similar to our scale factor when it comes to dilation. So it's kind of the same idea here, not as specific as scale factor, but very similar. So we've got a similarity ratio. If polygons are similar, then we can also say that their perimeters are also proportional. Remember, P is the sum of all sides, okay? So that's as we go around, you can think of it as like the fence around a polygon. So that means if two polygons are similar, their perimeters are also proportional to each other, just like the sides are. So let's look down here at some of these problems where we're going to want to start listing corresponding pieces. So looking at number 1, and the directions here say list all congruent angles and write a proportion that relates the corresponding sides. When we have a similarity statement, it's very similar to a congruency statement. So all the corresponding points are labeled in order, just like they were before. So we know J corresponds with P, K corresponds with M, and L corresponds with N. So right away, I can see these corresponding angles, right? So J corresponds with P, K corresponds with M, and L corresponds with N. What about the sides? Well, the sides are the ones between the corresponding points, right? So between J and K would correspond with between P and M. Then we have another set of corresponding sides from K to L would correspond with from M to N. And the last one, of course, we have L to J would correspond with N to P. So now when we fill in the information in the table for angles, remember all angles in similar polygons are congruent, corresponding angles. So J and P are congruent. So angle J is congruent to angle P. And then K and M are corresponding, so they are congruent. Angle K is congruent to angle M. And then L and N are congruent. So angle L is congruent to angle N. Now, when it comes to the proportion of the sides, here's where it's a little bit different than scale factor. We do not have to do new over old. There really is no new or old for us, right? We're not performing any transformations. We just are already given two figures. So you can set up the proportion whichever way you want, but you have to be consistent. So if you're going to start with this triangle sides in the numerator over this triangle side, then in every following proportion, you need to do this one over that one, or vice versa. If you start with the first one and put this in the numerator over that one, you have to be consistent. So like if I start with JK here and I do JK in the numerator, JK corresponds with PM. So I'm going to put it over PM. Here is our similarity ratio. If we had some numbers here, this would be a similarity ratio. So it's equal to the ratio of any of the other sides as well. But it has to be, again, I started with JK, so I need to start with another side length from this triangle. So the next one I could do is JL. So if I do JL next, JL corresponds with PN. And there is the second ratio setup of the side lengths. And then the last one, let's say KL. And that corresponds with MN. And so there's the proportion. It shows how the different sides are proportional. The ratio of the one triangle to the other one is proportional for all the sides. All right, let's check out number 2. So in number 2, again, we've got our similarity statement. And this is something I didn't quite mention in the first one. This symbol between the two, you might have guessed, it's a little squiggle. It means similar. That is the similarity symbol. So that means that they're similar. So triangle XYZ is similar to triangle RYS. So we've got some similar angles. X and R are corresponding, not similar angles, really they're congruent, right? Corresponding angles and similar polygons are congruent. So X and R, then we have Y and Y. So Y is corresponding with itself. They share angle Y. And we have Z and S. So Z and S are here. There's our corresponding angles. We can go ahead and fill that in for the angles piece, right? Angle X is congruent to angle R. Angle Y is congruent to angle Y. And angle Z is congruent to angle S. Now let's talk about the sides. So XY is the first side for the first triangle. And XY corresponds with RY right here. I'll just do it above a little bit so we can tell. And we have YZ right there, which corresponds with YS. And last we have ZX, which corresponds with SR. So when we set up our proportion, I can start with the bigger triangle or the smaller. Doesn't matter, I just have to be consistent. So let's say I start with YR. And it is over YX. That's equal to YS. Again, I'm starting with the smaller, and then I'll go to the bigger, over YZ. And then it's equal to RS over XZ. And that would tell us the ratio of the sides. All right. For this next one, take a second and see if you can fill in the angles and see if you can do the sides. Pause the video and fill that out. make sure you've paused it and filling this out on your own before you check with my answers. All right, hopefully you have filled in your own work. Now let's go over it together. So what are the corresponding pieces here? Well, we've got J and Q first. So J and Q are corresponding. And corresponding angles are congruent. Next, we have K and R. So K and R are corresponding, and corresponding angles are congruent. Next, we have L and S. I'm just going in order for both of them, and we know that corresponding angles are congruent. And the last letter is M and P. Those are corresponding, and we know that corresponding angles are congruent. Now, in this example, we have two quadrilaterals, right? It really doesn't change much. We just have 4 sides instead of 3. So I'm going to go around again the same I did before. First, start with J to K. So from J to K right here. And that corresponds with Q to R. The next one, I go from K to L. That corresponds with R to S. Then we've got L to M, which corresponds with S to P. And last, M back to J, or completing the quadrilateral, is corresponding with P to Q. So now we're going to set up our similarity ratio. I'm just going to start with the first over the second. So the first side is JK, and JK corresponds with QR, and we can see that those are the 2 red sides. Then we've got KL, so this is equal to KL over, next is RS, and notice those are the 2 green sides. Then we have LM, which is corresponding with SP, which are the purple sides. And the last one's MJ, corresponds with PQ. Those are the pink sides. Oh, and that went off a little bit. I'm sorry about that. So there is your proportion set up for the sides of this one.